So we are starting with a session which is session 2, Future Trends and Challenges. So for this session, the chair is Mr. Richard from IEC. Welcome, sir. The moderator for the session is Murugesan, sir. He is former DG CPRI. Welcome, sir. The key speakers on the topics which we had selected for the future trends and challenges, we have Subhadip Raychaudhuri, sir, who is Head Engineering Energy Audit GIS and AMI Applications from Tata Power. Welcome, sir. Then we have A.K. Rajput, sir, who is former member Power Systems CEA. He is joining us in a minute. He'll be seated next to Subhadip, sir. Then we also have with us Miguel Martinez, who's Senior Business Manager from UL Solutions. He is with us online. Welcome. Then we will have with us Mr. Gopal Nariya, who's Vice President BRPL. Welcome, sir. Thank you, sir, for joining us. Then we have with us Mr. Kishor Narang, who's founder Narnix Technologies Private Limited. Welcome you, sir. Thank you. So from now, I'll hand over to Murugesan sir to take this forward and Richard sir for his special address and to start the session with. Thank you, sir. Yeah. And
thank you. Thank you very much. Welcome back. I hope you share the excitement of the session this morning. It was a very, very good session, actually. So it's the 9th workshop that has been organized by ISGF jointly with the India Smart Utility Week. And I think this morning the turnout was probably the best we ever had in this type of quite unique workshop. And also I think the presentations were really up to the expectation regarding presenting some emerging technology and the standardization landscape relevant to those emerging technologies. So this afternoon, we're going to actually push the envelope, pushing forward the timeline, considering future trends, and touching upon very important dimensions, which are the regulatory framework are absolutely pivotal because they are enabling. Also, they are bringing potentially a lot of constraints that hopefully are actually giving borders to make sure things happen. So this is really, it's not just miscellaneous or something that comes after. It's really something to consider firsthand. And it is great to have this on the mind map as a target. And also, we're going to touch upon a very special dimension, which is that standards are interesting. We said it's very important, but actually standards are of no use if you cannot demonstrate that there is a compliance. And therefore, everything about certification is absolutely critical. And once again, I consider this has to be put on the forefront when we want to look forward on the timeline. And we will also have some application cases and some feedback or insights relevant to what we should think about targeting for the future. Without any further ado, I'm sharing here this session with my dear friend Murugesan that I remember visited your SEPRI, your organization, years ago. It's a very, very impressive research organization. Of course, this morning we had the current Director General, and it's a great honor being on stage with you today, and we're going to team up until the end of this 2 hours session. And basically the program is that we have from now to 4:30 5 speakers who will cover the targets I mentioned, and after that we might actually share some takeaways, and we will close anyhow at 5 p.m. not later. So without any further ado, Murugesan, you want to head?
Good afternoon, friends. It is a great privilege to be here, especially the session. This is IEC, Smart Energy, which is the core of the entire power systems. And the standardization is the heart of the system, which we are driving maybe for last 20 years. It has not percolated. Still it has not percolated. And we have not received the benefit of the standards use. So you take any of the components of the smart grid systems, 8 or 9 systems, I think excepting 1 or 2 systems, integration has not taken place properly. And when we look at it, very few utilities understood the standardization itself. Still we are finding it difficult. You take in a AMI, beyond meter collection and all such things, we never reached any place. Forget about CIM, all such things. So still the problem persists, though we are talking about smart grid systems for last not less than 20 years. So the standardization, understanding, especially utility side, it is slightly missing. So it is paramount to understand the implications of standards, and every standard is available for every segment of that things. And we are very fortunate, every year we get Mr. Richards, and in fact you can put his CV, no? You can and you have the right opportunity to interact with a person who is at the helm of that standardization, especially smart energy. So you will get what you want, and the source is available here. And it is my honor to introduce Mr. Richards because many people may be new to this this particular program. He is driving the whole thing. As you can see, the short CV itself talks about it, and he is a recipient of IEC 2011 Lord Kelvin Award. It's one of the topmost award. Very few people get it. And he chaired the IEC System Committee on Smart Energy, TC8, that is system aspect for electrical energy supply, PC118 Smart Grid User Interface, TC49 Nuclear Instrumentation and Strategy Group, Smart Grid, and President of a consulting practice, that is industrial strategy, complex system engineering, cyber security, standardization, what not. So friends, you have to make best use of the topmost resource available here, and you can go on telling about him. He has contributed a lot, and I am honored to introduce Mr. Richard to these members. Thank you very much.
Thank you. Thank you. That's really kind from you. Thank you.
Thanks.
So should I start with the speakers?
Yeah.
Yeah, so first of all, introducing Subhadip Raychaudhuri sir, who's Head Engineering Energy Audit GIS and AMI Applications Tata Power. Sir, I request you to please come over and give your presentation, please. Thank you so much.
And maybe you can go through that. It is my privilege to introduce Mr. Subhadip Raychaudhuri, and we have interacted quite a long time. The reason is that in India, very few utilities are taking return on investment on the, especially on automation, whether you talk about AMI or distribution automation or SCADA or related things that, and the Tata Power is one among the top utility which utilize, get the most benefit out of the what do you call, the smart grid systems integration, I like that. And contribution of Mr. Subhadip is great, whether it is in a Tata Power or Calcutta Electricity Company, where he has contributed a lot for SCADA and automation systems, and we are privileged to hear from him, sir. Thank you.
Namaskar, I am Subhadip Raychaudhuri. Let's start with this. Can I have this over here? My eye is a bit defective, I can't read it that far. Can I have it on the screen? Oh God. Okay. Okay, I will try. We work in Tata Power Delhi Distribution Limited. We serve 29% of Delhi consumers in Delhi, and these are our operational performance parameters which are given to you, what we have done in the past 20 years. And if in case I am allowed to say this, in a nation which is obsessed with AT&C loss reduction, maybe because of accumulated losses, that is not the only thing that a DISCOM is supposed to do. If in case your services are good enough, customers will flock to you, and along with that, if in case your service is good, your consumers will be happy, and then we are growing all across India, and presently this year, these are the things that has happened. Successful peak load management, all-time high of 2481. The load increase in Delhi has been humongous this year, 11% load growth. Not only us, even BSES has made that. We needed to do that, and this is what gives the greatest happiness, that without load shedding, power cuts, we have been able to do that. All-time high billing efficiency of 94.5%, smart meters helped, but that is not the only person over there. Smart meter targets are always there, 5.3 lakh smart meters installed. And this gives us the most happiness, which we have written at the bottom, that is, we have won the prestigious Deming Award. First utility, not only in India, but maybe amongst the top 3 utilities which has ever got Deming Award over here. Can't I have it here on the screen? So, look. So looking into that, one patent has come through this year ultimately on self-generating breathers. Along with that, in Smart Grid Index 2024, we are at number 9. Though the ranks are shared, we will show that to you. Starting from number 24, we are at number 9, but there are many consumers over there. Customer service ratings, IPDS ratings, distribution utility ratings have put us in a good place. This is the Smart Grid Index 2024 by Singapore Power, where you will specifically see that these are the 2 development points that we have. What we have done, tick, is good, but these are the things that we have to work upon. Data analytics, something more. Along with that, supply reliability, a bit further. Now, while we are studying this, the key technology trends which are driving the global energy transition, if in case you have a look, these are the 4 things that we have started working upon now, because these are all quite deep technologies, and because of that, we will need a lot of time in developing them. And India, it may seem that we don't need it immediately, but these are the things that will keep on coming to you at all points of time. Along with the data centers with SMR, smart module reactors, this is something that will be hotcake in days to come. With whether India gets the licenses to go further with your nuclears is something that we have to think about, but these are the things, and this is the energy forecast which will come in the data centers. And data centers in big cities will give you the highest portion of load growth in days to come, because industries are shutting down in densely populated areas. It's all data centers and shopping malls presently. Along with that, CO2 storage and conversion to chemicals, it will gain traction in days to come. Pretty early days today, but this is what will drive the global energy transition in the days to come. Rather early, going by Indian sense, but this is something that we will need. I can't move the slide. Can anyone? No. I've told them, sir. Please be seated, sir. I've told them. Please be seated. Right. This is the thematic areas of emerging technologies. Solar PV, thermal generation, distribution are actually reading through them will add very little value, but these are the things that we want to introduce, and this is something. The reason is deep technology will take a long time. Efficiency, quality, safety, yield improvement is something for the existing systems now, so that they stand the test of time well. Along with that, solar PV, microgrids, distribution we are looking for your feeder pillar leakage current detectors in a very big way so that we can integrate them back end. But it's something that's not happening, that's not meeting our satisfaction much. The thing is carbon net zero by 2045. This is not a story, this has to happen. And if in case we believe what the newspapers say, 13 out of 20 most population, most polluted cities of the world are in India. So it's important that we start looking ahead. Looking into this, once, next slide please. Emerging trends in utility industry, these are the things that needs to be done. Decarbonization, grid resilience, immersive technologies, utility mapping, digital twin. We are working on all of them, but with limited success. If in case you look at operational automation, that automation itself has become so costly now. And more so with India deciding that they will be depending upon the public telephony or the communication will be on rent from your cellular service providers. Presently, not even 1% of their revenue come out of our systems. So the kind of attention that we are going to get is something that we need to think about additionally. Need for innovation, because variability in fuel prices, it doesn't give you much time to react. Therefore, that basket has to be thought of in that way. Cyber attacks are a reality of the day, and unpredictable weather, blame it on whatever, including global warming, is something that we have to think about. Higher penetration of EVs in the grid, it cuts the load peak out during the day where you have it, but the night peaks are increasing at an alarming pace. And more so if in case Delhi has seen a large growth in EV buses. The strange part is they also recharge during the day peak. They have not been able to shift it ahead and on. So looking into this, consumer behavior is also changing. One more slide. So standardization, back please, please. Standardization must pave way for innovation. This is something that I would like to tell everyone. That is what our requirement is. Every day new technology comes up. Accepting it becomes very difficult, and whether our standards are allowing innovation to happen is something that needs to be worked upon in a very really fast manner. Along with that, all your products, services, your integrations with existing systems, integration among systems, interoperabilities. How do you build a standard for that? Even now, once you select a communication medium for even your smart meters, at that point of time, you get tied. You get tied to a technology which may not stand the test of time. Therefore, that way ahead is something that we need to look into. Caution of data protection and cybersecurity are real threats. We are always working on it, but not reaching much far. miles to go on this field. That's all from my side. I have 2 more slides, but I think 5 minutes is what was given to me. Acha, should I continue, sir? Quantum technology and energy systems. In quantum computing, quantum sensors, quantum materials, quantum communication, we are hearing a lot about it. Very little is actually being done in India. If in case we have to make India happen, make in India happen, at that point of time, it's time that we started work on them. Gridspertise, Tokyo Tech, in EV battery monitoring, it's all good. But let's come to your energy sector, solar cells and higher efficiency batteries. Because without batteries, discharging at night, it will be very difficult to manage the night peaks that are coming into the system. 50 megawatts of buses are being charged at night in Delhi. If in case you go further ahead, the last slide, if in case you allow, the emergency, this is a demonstration that we did, we wanted to speak today with you, along with NEDIS. This got an award, we call it Shakti. Over here, MVLV transformer, along with that battery energy storage, we have a panel room switchboard, and of course a meter row. All of them have been done. This has got ISGAN award this year, sir. And that's how things are. So, going ahead, now standardization. Without standards, we don't like buying anything. Therefore, evolution of standards is a continuous process. I think we have to move, be rather on a more fast-paced approach so that we can also look ahead. That's the requirement of ours. Thank you. Thank you very much.
Well, thank you very much for actually sharing quite deep thinking. It's really mind-boggling to see how you've been dividing by 10 the losses over 20 years. That's
90% of it reduced when there was no smart meters.
Oh, okay.
The truth is, a smart meter is a device, right? Sir, I may buy the costliest camera of the world, Pentax, Canon, but that won't make me a good photographer, right? It's the skill of taking a click is what matters. If in case you put up instruments which you cannot use, it's of no use. And moreover, if in case you don't have instruments today, do you have the intent of doing it? If in case it's yes, you will get it done. That's it from my side.
Thank you very much. So it's really you have. Oh, can you stay here with us, please? You have an innovation showroom, right? At TPDL, right? And it is still going on and still improving, and everyone can still visit this, right?
A smart grid lab, as we call it.
Grid lab.
Yes, yes. We have 15 panels now. We change the panels as and when a few become old and a few new things come up. And anyone can come, sir. I think on 22nd there is a visit planned as well.
Yeah, so this is a very innovative approach where you have been dedicating like booths. There are, so you said 15, there are 15 booths on demonstrating a specific technology and all what it can bring, and you've been partnering with whoever has something to offer there. So this is quite exemplary, and of course you've shown that you've been awarded at the Smart Grid Index a very good position. So we thank you very much for sharing the thinking and some priorities that are really sound, and we could wonder why not more Indian utility can actually do as such. Of course, you may say, "Oh, it's thanks to the exceptional people at Tata Power Delivery," but there might be another secret.
Actually, sir, in Tata Power, when Tata Power Delhi was formed, Delhi distribution was formed, it was a bigger distribution utility than we had in Mumbai. And once we had it, so the distribution sector development started happening here. So over the past 22 years, the culture development it takes time. So that has happened over here, sir.
Okay.
So that's the reason why.
Okay, that's a good hint. So now I'd like to ask if anyone in the audience might have a key question or a teasing question here.
Yes, sir. You talked about.
Could you please introduce yourself?
Yeah, my name is Shishir. I'm a product manager at Landisgear. Yeah, we met. Yeah, so just wanted to know. You talked about quantum computing in energy sector. Okay, so are there any use cases that you are vying for as far as quantum computing is concerned?
Can you kindly go back to that slide? There is an use case there. I have shown it there.
Okay.
I did not speak about it. I'm sorry. No, the one after this. After this. You're going before. Just before the. Go ahead. Please go ahead. Next. Quantum computing use case for grid resilience and flexibility. This is something that Gridexpertise has done. And this is something that we want to emulate. The thing is, presently we are a DISCOM. Now, if in case you understand our bus bars, we are historically drain bus. We take power and then. Today, with time coming up, the thing is, microgrids and renewables are a reality of the day. Right? Now, if in case there is even a grid failure, the solar panels that we put up today is not capable of isolating and running itself as well, because it doesn't have battery support, right? Now, we will be putting here battery storage at multiple locations. I think in Shakti I have told you something. So somehow we will have to manage it in such a way so that once that prediction even reaches us, we can run small pockets well. So that is a use case that we are looking up to, number one. You see hybrid optimization of DR models?
Okay, so this is already getting tested, implemented, like in the lab.
Can you speak loud?
Okay, so is this already getting, like, are you already testing the waters as far as these use cases concerned already?
It's in labs now.
Oh,
we are working upon it. We have a tie-up with a few people. We have a tie-up with a Canadian university as well on grid resilience, Rajput University, and the results will be out by April. By the time the summers are out, we will do 4 things over there: short-term load forecast. Along with that, in ADMS, we will have the real-time data flow. Real-time is a misnomer. It will be 5 minutes late. On the basis of that, we will adopt overloads and fault restoration simultaneously.
Great. Thank you.
So on this Gridexpertise technology, it is more grid edge computing than anything quantum. I mean, but this is very interesting piece of equipment. I was at Gridexpertise last week in their lab, and they have quite unique a capability to actually study ahead where you could plug those edge computing capability, and they are using RTDS.
Real-time digital simulator.
Yeah, real-time digital simulator, which is a hybrid simulation where you can couple a digital model simulator with some real equipment. And this is a quite teasing approach. And I know one application, they did not call it, it's not Gridexpertise, they don't call it quantum or whatever, it is called IntelliTeam. I don't know if it rings something to some of you. IntelliTeam, it's SNC. It's a US company where they are providing, well, like a quantum calculators that they can install on top of poles, different poles, in some remote area, meaning that you do that when you have an issue with communication if it's really remote, it's difficult to have to rely on a communication mean that would actually bring sensor information to the central system and then back sending orders to be able to diagnose if there is a fault somewhere, to disconnect and reconfigure actually the local network. And so they install those piece of equipment on top of poles in remote areas, and those equipment are collaborating in between them. Only, it doesn't go to the central system. And they are able to, so they share actually information on the electrical status of the grid. They can disconnect, and they decide collectively how to reconfigure locally to be able to reconnect very quickly. I think this is an incredible use case. I'm not advertising for the company.
Dynamic reconfiguration is the name that we have given it.
You have given,
And,
okay.
we will be working on it, yes.
And SNC did not even invent or create that. They purchased a startup company from from East Bay of San Francisco area. That's a good friend of mine was the owner of that startup. But this is really the kind of thing we can do, we can count on. And this is quite unique. This grid expertise, what they call it quantum edge, is a really, really good piece of equipment. When you look at it, it's a very high quality. Okay, are we good? You got the answer? So we're good at this point. We need to thank you very much. Thank you very much for the content and for the discussion we could have on this topic. And of course, everybody is encouraged to go and have the visit to their Smart Grid lab.
Friends, next speaker is Mr. A.K. Rajput. This is on a regulatory framework governing the integration of distributed energy resources. Friends, it is my honor and privilege to introduce Mr. A.K. Rajput, with whom I worked when I was working at Central Power Research Institute. And the Central Electricity Authority is a very important organization, a statutory organization which governs this all electric activities in India, and it is a binding on every utility. You can standards we can forego, but the regulations of CEA is binding on us. So we are very happy to hear from Mr. A.K. Rajput, who was a member Power Systems. He is equivalent to Additional Secretary to the Government of India at Central Electricity Authority, and he is a master's from IIT Delhi, and he worked in the area of power systems, standardization, and he was also a chief engineer R&D, with which CPRA and most of the R&D organization need to work, and he played a very important role, especially on integration and renewable, all such things. And he is the best person to talk about the regulatory framework like that. Over to.
Namaskar everyone. Good afternoon. Jai Bharat. That is, we call Great India, right? So, thank you, sir, and thank you, Murugesan ji. I have been given this opportunity. I do not know what they want, that on which topic I should speak. There are many topics, and Raichaudhuri have told many things and many high-end things, but I will make it the simpler one, which is easy to digest and easy to understand and easy to deploy. So should I limit myself to DER and also the standardization part of it? The meters, meter. Okay. So some, because and how much is the time? 20 minutes. 20? Including question, 20 minutes. Yeah. So when I am crossing the limit, you just tell me. And Murugesan Saab and myself have grown together, and abhi baal thoda still some not as grey as of our old friend Narang Saab. So by that performance standard, he is more knowledgeable. The wider it is, the more knowledge is there. So we are little knowledge having. So I thought let me continue the things of these standardizations. So what evaluations are going on and what are the future trends and the challenges from the DISCOM point of view on the standardization, and the metering basically is the much talked subject. And for kind information, I have completed my tenure as a government servant, and what you were saying that equivalent to this and that, my philosophy is that we are all equivalent. Just a minute, I have to take him. पीयूष भाषण दे रहा हूँ.
You can tell the Prime Minister Modi to maybe avoid calling you when you're on stage.
No, he is my classmate, so I cannot ignore him. And he is maintaining the grid of the largest state of UP, Uttar Pradesh, the state of Mr. Yogi. So he is more powerful. So we have to follow certain protocols. Who is calling and who is not calling. Even if my wife had been there, I could have ignored. But since
We understand.
okay, so standards should be as simple as possible. We should not make our life miserable by making the standards and the procedures and the techniques so typical and so complex that instead of technology, Murugesan Sahab, instead of technology, we keep on going to the courts and the higher authorities. It should be as simple that as we are hungry and we are going to take food, whatsoever it is, it should have the quality. So that's the meaning of the standards in the simple term. Our standards should be developed in such a way that they are more simpler, more agile, and they give the robust product, a very robust product which could last say for at least 5 to 10 years, because meter is an electronic component and its life is of course limited, but it should not give way say after just 2 years, and it requires further changes and it requires further programming, further upgradation and all those things. See, this rests on the policy makers also. They should think several times, at least 10 times before taking out a policy, because today they decide the policy and next few months later they say no, that you have to reverse, and what you have done you undo it. Reason being, the consumer meters particularly are in millions and millions and millions. It's not a one thing that some vehicles are there, they are in numbers in thousands, and some defect is there and they could be recalled. It should not happen. पीयूष बताओ क्या है? Sir, so standards are ever evolving. They will keep on changing. See this bottle, this is rectangular. Some bottles earlier is smaller but in round shape. That's the meaning of standardization. But if you see the lid over that, it has a standard size even for the 1 liter bottle, 2 liters bottle and the 250 ml bottle. So that is the meaning of standardization. And standardization helps in controlling the inventory and also help in the greater productivity and the competition as well, because if the things are standard and the people know that they are going to develop something, they are going to manufacture, new manufacturers can come and they can offer the best of the product. Along with the standards, what matters is the sufficient margins built in that from the side of the manufacturer itself, because the product quality after use talks of itself and establishes itself. There are certain brands also that okay, whatsoever is there, all the things being equal, but I want this particular brand. That should be the capability of the manufacturer if they offer to the utility and if they serve to the consumers. So these are certain things that can come with the ever increasing the practices, good practices, or what we call the best practices of manufacturing, transportation to the site, installation, and the use, and the naturally the programming part and other things. So many bugs should not be there when the things are produced and are manufactured, and the person keep on doing or remotely doing something or other, and creating lot of confusion in the mind of the people, and creating mistrust that what they are doing, they are, I think, manipulating something, even though the utility personnel must be doing best of their efforts to rectify certain things, but people's mind are like this, they may or may not trust. On the utility part is that when they are using these standard things and the quality products, they have to build a trust among the consumers, and that trust building is the success. Along with this is the power quality. I would understand that when the talk of the meters, that the power quality measurement or the power quality monitoring and reporting should also be an integral part of it. That would be the long lasting features that could help the utility in devising the certain things, that where they have to put the filters and other things or some static devices, STATCOM and etc. at the distribution level, so that whatsoever they are supplying to the consumers are lasting long. What is happening? Lot of fires are taking place, and reason is our devices were built, our system were built for the pure sinusoidal wave, but now lot of DC components, lot of harmonics, and lot of power quality issues are there, and that's why that is one of the contributing causes to the large scale fires in the buildings, either commercial building, residential building, or somewhere else, particularly in the hospitals. So that we have to keep in mind when we are developing the standards and when we are talking of the standards for any of the product, not only of the meter, because meter is not only the meter, it is so called the smart meter, and it's basically the AMI and the total system. So we have to adopt the system approach and not only the individual components. There has to be a transition time. Of course, when the evolution is taking place and the technological development is taking place, there has to be a transition time, and that transition time should be enough that whatsoever is already there in the system that gets consumed and whenever the new products are coming and the new standards are being enforced, and the standards are being enforced by the regulations. So regulations have to change in such a way that the transition periods are kept in mind. So that is one thing. So naturally the DISCOM would not like too frequent the changes and too frequent the installation, reinstallation, and dismantling of the whatsoever the equipment they have placed. Then comes the interoperability and the compatibility. It is the systemic requirement that the utility would not like to stick to the only one company, or what Mr. Raychaudhuri told, that if you get engaged to one company and you remain engaged to that one company, the chances are there that some foul play may take place at a later stage if both are not truthful to each other. Then additional option of devices from other consumers and other suppliers, they should also be given chance, otherwise the competition will be killed. That has to be there. And when the competition is there will be a fight for improving the quality within the existing standards. So that is the point which I want to make. Regulators have to see as a long-term approach and also the cost factor, because the cost is to the utility and that utility pass on that particular cost to the consumers. So whatsoever the cost or whatsoever the capital expenditure is to be invested in, say, particular installations, whatsoever it is, that capital could be invested at somewhere else and for some other useful purposes as well. For this we have to have and we have to devise some portals and some feedback mechanism where the consumer itself can give the feedback. The utility personnels who are the users of the devices and the equipments, they can give the feedback to the OEMs. So that particular type of the closed loop feedback has to be there. Then only the things can work. Otherwise, working in isolation, you may be doing certain thing, but say it may or may not be acceptable to the utility, and it may not be at all useful. You might have developed something, say you might have developed a truck, very heavy duty truck, but the requirement is of a car. So that aspect has to be seen. Then cyber security is era, and everybody is talking of the cyber security. Cyber security is such a thing that that is the data privacy has to be maintained. That is the prime requirement of the cyber security aspect when we talk of. Well, of course, it is a very larger term. It can disrupt this, it can do financial manipulation, it can disrupt your supply, it can manipulate your data, and it can corrupt your data, it can say erase your data fully. There are so many things. It comes from the practice, and by adopting the standard practices and the whatsoever the cyber security standards and the practices are there, those have to be, and naturally daily new tricks are being applied by the cyber hackers. So we have to be very careful, and we have to devise our own measures. Isolation is the best one. To the extent possible, the critical applications should be isolated and they can be maintained safe. Sometimes what happens that there are certain suppliers, and we may get trapped, the utility may get trapped by their design. They may or may not give the exact thing which is required. They may leave some, you can say, some patchwork to be done later on. And one thing is that the AMC thing, I am talking very bluntly, because AMC are sometimes very costly as compared to the original installations. So kindly maintain a balance. That is my feeling and my appeal also from there. And the one more thing is the type test requirement. Any standard, they does not specify the type test periodicity. Sometimes in India we talk type test validity. What is the validity? You have passed the 10th standard exam. So will it become invalid after 5 years? And we specify the type test validity in our tender, and we write the word that is the wrong word. The type test validity will be of 5 years, and after 5 years, when it is going to be over, the type test has to be redone. Standard says, or the standard practice is that if there is no change in the design or there is no change in the standards, the type test need not be repeated, because type test is a cost consuming effect on each and every model of the piece of the equipment. It is applicable not only for meter, for every other equipment, for circuit breakers also, transformers also, and conductors also. So 5 years is too less a period. 5 years period has been done or has been, say, rationalized by some of the utilities that it should be 5 years. But in fact, it should not be. It should be as per the standard. If something has not changed, we need not necessarily. And if the utility wants it, that he or she has to pay the cost of that particular type test. So this is about the type testing of the equipment, because every standard, either IEEE, IEC or BIS, our standards, they say that these are the type tests which will be conducted. Type test is for manufacturer, and it's a design validation test. Once the manufacturer is satisfied, is confident that my design is perfect, he can go for mass scale production. It is the, you can say, this one, it is the responsibility of the user also, or the purchaser also, that he gets the requisite test done out of the samples which are produced, and the procurement plans and the quality assurance plan, that he get the right thing. That is my view about the type testing of the equipment, because every standard necessarily have 3 types of the type test, routine test, and the acceptance test. And of course, there are some special tests. If a utility want, they are free to get it done. So privacy of the data I have told. One more thing about the standardization and what we system are developing, it's applicable to general, not only to the meter but to everything. The ambient temperatures are rising. Our testing is still being done at NTP, normal temperature and pressure. So we have to think of, I think a debate should be done. What should be the testing temperature in the lab. Earlier the maximum ambient 40, now they are coming 50 and 55 also in some locations. Still we are testing at IEC says 20 plus minus 5, Indian standard says 27. So we need to be enlightened, we need to have a thorough review of certain things, because the equipment which we are procuring now will be lasting say for many years to come. So you can comment later on, certain more things are there. Are you telling time?
If we want to have a discussion with you, maybe we should start some questions if you would agree.
Flow will stop. You note down your question. I will tell few more things which will raise more questions.
Please,
yes.
Anyhow, it's an honor.
They will be very pleasant questions.
Go ahead.
Yes.
No,
yes. So this is about, because every electrical equipment or electronic equipment, whatsoever is the design, the basic design criteria is the ambient temperature and the maximum temperature the equipment can sustain. And we are doing the testing at some other parameters, whether that will sustain up to that level or not. I am not giving any decision, I am not saying this is my view or the authority's view, but it is my personal view. We should start thinking like this. One more thing is that the lab power supply is quite stable and pure sinusoidal, or if it is to be tested at DC, it is pure DC. But in reality, the power supply quality are having many pollutants. So that much margin need to be developed in the testing, and when we are developing the standards, those type of the things need to be included.
Excuse me. Actually, though when we submit your equipment for standard testing process, the customer can specify. Customer can specify for a particular things. He can tell what is that the equipment need to withstand maybe higher temperature or anything. So the standard it doesn't stop it. So the customer can
it is quite clear, but many of the customers, particularly say remote or somewhat less developed utility, they are not so smart. They follow what the big brother has, what the big brother is doing. Big brother may be in here, this area, Delhi, very comfortable place, but the smaller brother may be in that coastal area, Paradip and the Khavda area and like that, where the lot of corrosion and the many things, relative humidity goes to as high as 100 and ambient goes as 50 and 55. So he is not so lucky in terms of the knowledge, in terms of the practice, and he considers that Murugesan Sahib is the best one, copy him. So you need not be copied each and everywhere. Okay, sir. Another thing is the regulations. Most of the standards are say in 2 minutes? 2 minutes, 2 minutes only, yes. So regulations make the standards mandatory, because most of the standards they are voluntary in nature, but as far as metering standards are considered, in India the regulations have made that consumer meter have to bear necessarily the standard mark. Further, if the best practices of installation and operation and its regular operation are not done, whatsoever efforts we have put in, whatsoever capital we have put in, that will go waste. So that is a must. For that, we have to increase the capacity and the capability of the personnel, those who are dealing the systems. When we talk of the DERs, distributed energy resources, lot of simplification can be done. And there is a misnomer. From this forum, let me convey my feelings and convey my experience about this. We are talking of the 500 gigawatt RE and all those things. We are having more than 6 lakhs of the villages. Each village can have 0.5 megawatt, a mix of RE, some storage also, and of course all the villages are connected with the grid. Easily we can achieve 300 gigawatt of RE. So 500 gigawatt RE target, that is one way of attaining. Another way and another attempt is that large scale utility and solar rooftop. DISCOM can be part owner DISCOM, part owner the local panchayat or the local pupil. They get the implement, they become the part of it, they become the revenue earner, DISCOM become the revenue earner. Otherwise, DISCOM's financial condition going poor and poor and poor. This type of the song will continue for another century. The product in use speaks of its quality, and whosoever is the best will remain and sustain in the market. That is the established fact. Along with the installation of the meters and the sophisticated device and other things, what is necessary is that the data analytics must be done, and that data analytics being done, afterwards the useful reports for different levels need to be carried out. The energy mix or the energy purchase basket should be based on whatsoever the data is being received, when the peak is arriving, in which season the peak is arriving. Now we are again reading the newspaper headlines that we will be facing the severe power cuts in the summer. It's a usual thing. When there is a lot of heat, you have more thrust. So similarly, it is for the electrical demand. So why don't you plan in future or tell your people to moderate your demands? So that is this. Now the coal crisis will come, another crisis will come. Water naturally during these times in the reservoirs will be less. So it is basically the demand and supply, and it is basically the management and the planning and the practices you follow and the nature you inculcate. As Tata Power sir was telling, that buses they charge during the daytime. It should be in the night time when the people are not travelling and the buses are there. The electric supply, solid electric supply is there at 11 kV. So the buses could be charged during the night time and should be charged. So that should be enforced. If the meter could also be made intelligent, we can have the better standards of power supply, and that will be good for each and everyone. And of course, lot of power quality problems will be coming when we have the hydrogen type of the load and also the natural energy storage type of the load and EV type of the load. Just last sentence I will be making here. There is an investment to each and everything, and investment per node will be naturally lower if the large number of nodes are there. If we call say only say 100 meters, we will be doing some smart pilot and like that. So that is a pilot cost. But large scale rollout calls for the larger number of the nodes, that is the installation points, so that the cost relatively will be low. Thank you, sir. And now I expect many questions from your end, sir.
Well, thank you very much, Mr. Rajput. Thank you very much. It's a great honor having you here in this session. Well, standardization and regulation are very, very difficult topic, actually. And there are a lot of subtleties. Of course, standards are not standard. There are standards on many different aspects. There are standards on, well, safety or practice in the field. And that's obviously it's quite easy to mandate this because it's needed, and everyone can agree that they have nothing to lose. It's really for the good of everyone. Now you also have standards about connection of equipments to the grid. So this is also needed, and people are not arguing too much. Well, you have to find the best or the easiest, most universal connection standard. But there are also standards about technical solutions. And regulators very often have to authorize investments, right? They have to authorize a utility. So utilities have to put up a business case and propose the regulator to approve actually the investment so that the utility can recoup the cost of the investment. And this is where my question is, because you address a difficult topic, so I have to ask you a very difficult question. I barely ever seen any regulator around the world mandating or ready to mandate a technology or approve really and say we approve it, we request that the utilities are all using equipment that comply to this technical standard for a simple reason, because the regulator, well, in some countries, part of the world, regulators are changing every few years, but the regulators don't want to be liable about that technology. You never know. The technology, this could actually cause some issues later on. Who's going to pay? Who's going to be liable? So utility. So my question to you, the difficult question to Your Highness in regulation is, how do you cope with this question about mandating a technology?
Yes. Question is not very difficult. Question is simple. Because regulator in itself is nothing. Understand? Without the stakeholders, without the consumers, without the manufacturers and others, and also the financing bodies, the regulator is nothing. Regulator is empowered, has derived the power and a conscious decision based on the large scale consultation from so many. If the regulator is there, he may become a dictator, as you raised the question, right? Specifying particular technology is called in our terminology in India as monopoly. And we have CVC and CAG, Central Vigilance Commission, and Comptroller and Auditor General of India, and still there are higher bodies like CBI, Central Bureau of Investigation. So they are bigger than the regulator.
Okay.
Okay. So,
Okay.
so
That's a safety belt.
your
Okay.
each and every step is watched first by the public, next by say many meter manufacturers here, say Landis and Gear, Secure, this and that. If Landis and Gear brings one technology and I as a regulator say okay, his technology is best and it should only be mandated, nothing doing. It will not work in a democratic country.
Yeah, but in Japan, for example, for smart metering, the regulator, METI, well, the regulator is at the same time the Minister of Industry, but they mandated two things. They mandated Wyson Communication and G3 PLC.
Here we
They
have.
mandated it.
Okay. Here we have what is known as policy. Policy.
Okay.
Right? Under a policy, it can be done. Okay? Say we specify that in these areas, say agriculture consumer, they need not have any meter. That could be one policy. But regulation is there. Regulation says every consumer has to be metered. Regulator has to see the practical implementable aspects also. You may make very fine regulations like Vedas and Gitas, but a person who has just read only up to 5th standard, he cannot understand Vedas. So regulation is like Vedas. And similarly the standards. Even if after say 40 years of service I start reading these standards, it looks as afresh as the chemistry book for me. And it's with others also. Everybody feels across the table, he knows better. He knows better. Of course, Anandji knows better. Rameshwar Duveji, Anand is his friend. Okay, I am remembering him. So, we feel they know better. And they feel that I know better. So, it is swinging between the two. So, some balance is to be maintained and that comes out in paper. So, after 10 years, it will come, oh, whatever we done has some deficiency, let us correct it.
So this is the power of after retirement.
And say Japan example you told, we also have the similar policies like this. Say there is a CRGO material for distribution transformers and also say amorphous metal. We have allowed both by policy. And there are some states or some governments, They say no amorphous because it's dangerous to the environment.
Thank
So,
you.
environmental considerations and the bearing capacity, affordability, that decide which type of the standards, which level of the standard and which level of regulation has to be. Say we have some affordability, so we will consume that much calorie only. We cannot consume 5000 calorie per day and like that. So, that's the way of life.
Thank you. Thank you very much for addressing this very, very difficult and touchy dimension of
No, sir,
electric sector.
If we are in the shoe of others, that is known as empathy, we can understand and make the life simple. If we say our head is high, some gas filled, polluted gas filled in the head, things will not work. So,
Thank
it
you,
is
thank
energy
you very much,
transition, everybody talking of net zero, also talk of refining the minds.
Thank you very much.
So, that is known as that in our sophisticated way we call the capacity building. So, capacity building is must. You may have a Mercedes or the BMW or whatsoever, but if you do not know the driving, it is of no use to you.
It is very wonderful in a frank talk.
Excellent. Excellent. Thank you so much for, and great honor having you here and accepting having this direct
We are old
discussion.
friends. We developed many things which could suit to our country. Some countries have gone to the moon. It's not necessary that every country should go to the moon.
Thank you. Thank you very much. Great honor. Thank you, sir. Thank you very much.
Thank you.
It was wonderful in a frank talk from especially a bureaucrat. In the sense, normally the bureaucrats will talk very polished way, goody goody. But I'm really happy to see that a senior official from Government of India openly talking his mind, what is happening here. Thank you very much, Rajput ji. Only one statement. In India, he talked about so many aspects, but here still the standardization and writing the specification, though the CEA has given a CEA manual, it has not percolated, excepting very few utilities, advanced utility like Tata Power or some advanced utilities, they rely on standardizations or reliance, all such things, they go the specifics of writing specification and procuring equipment and do like that. But most of the government utility, I am sorry, because I am associated with many utilities, even standard itself is not there available. No standard, but it is only copy and paste specification routing. I have 1977 specification. So friends, we have a very typical situation in India, so we don't like to talk beyond that. Thank you very much. Maybe that CEA can do something on this. See, especially on government utilities. First of all, there is no standard section at all, no quality section at all. How do they procure the equipment? How do they install the equipment? What specification they write? Absolutely, it's in a very chaotic condition. A cable which comes with outdated standards. Can you imagine? 1977, it comes with a 150-page specification. 1977 withdrawal standards. This is a very pathetic condition. I think CEA should do something on to establish a quality cell and with a standard. They have a 20,000 crore, 30,000 crore company. No standard is available. And I asked, how do you write the specification? No, you are only copying and pasting. Some utility, it was going on throughout India. So something CE and they have to do something on quality assurance.
Sir, one correction is there. CA can do many things, but not Hello. CA can do many things. CA are also a bunch of human beings given certain specialized specifications, means assignments. But it is the public, it is the other wise people, I would say, other intelligent people, who have to give feedback in this era of internet and emails and the portals, so that CA also opens his eyes much wider. So that is your role. So you also do, you means the public and the stakeholders also do their role, so that they are forced to do much better. They are trying their best. They must be trying their best because they are government. But still government need the support. Without the people, the government cannot exist. That's my view.
Thank you, sir.
You have a lot of experience of the, say, international experience of the lab, setting of the cyber security lab and others. CA, unfortunately, is not having any lab. They are dependent on the lab of CPRI and ERDA and some manufacturers lab.
Yeah.
So, lot of transformation has to take place and lot of interaction has to take place. Somehow, a sad affair is that it is not happening.
Yes.
Yes.
Thank you very much. So the next topic is on testing and certification of DER interconnection by Miguel Martinez, Senior Business Manager, UL Solutions, which actually he is from UL, and UL doesn't need introduction. You know, it is a well-known organization, especially on safety standards, testing and certification like that. And we have one of the best speaker, especially on testing certification. This is very, very important because the DER is going to dominate. So the certification is very, very important, and we are happy to introduce Miguel Martinez to this audience, though virtually. And he is a doctorate in physics, specialized in grid integration, and he joined with what you call UL as testing, inspection and certification. That is a major activities of this organization, UL Standards Organization. And he worked in various testing of activities in renewable energy sector and certification. And in the recently, you know, he was involved with a very large integration of 9 gigawatts grid code compliant of power generating systems, PGS and power plants and power generating units, PV inverters, storage, converters and power plant controllers. He worked actively with more than 60 different grid code at world level. We are very honored to hear from Mr. Miguel Martinez. Over to Miguel Martinez.
Over to you. We cannot hear Miguel Martinez. Can we check? And Mr. Martinez, you have 10, let's say 10 minutes presentation and 5 minutes Q&A, if you wish. Yeah, we cannot hear you yet. Could we speak?
Can you hear me?
Yes.
Hello?
Yeah, we do.
Okay.
Thank you.
Sorry. Can you see me?
Yes, also.
Okay, perfect. I will share my screen with the presentation.
Yes.
Can you see my screen?
Yeah. We can see.
Okay. Thank you. At the first, thank you for giving me the opportunity to join this event. I hear a lot of very interesting information, and I think that it's something that I will explain is something that is happening around the world with the integration of renewable energies into the grid. So my presentation will be focused on something that It's critical for the integration of renewable energies because we are talking about sometimes about safety of the products, about the interconnection capability for electromagnetic compatibility issues. But something that we need to think is for why we are requesting the grid code compliance. When we talk about grid code compliance, we need to think about the number of renewable and the number of equipments that we are integrating into the grid. This integration of renewable energies affect to the stability of the grid in terms of voltage and frequency, and we need to define that these integrations shall be in a safety manner to give us the possibility to not stop the operation of the grid. What are the grid codes? Because when we talk about the grid codes, before my presentation, in the introduction of my colleague told us we are working with 60 different grid codes. The grid codes basically are the rules defined in each country to to give the permission to connect these generators to the grid and to define how the uh, utility or the local authorities define the rules for this interconnection to the grid. As I said before, we as a big difference with other standards. I hear that there are people from EIC standards committees. We have one safety standard for some type of generators that is worldwide accepted. That this is a great advantage because we can use this standard to the installation of different countries. But in terms of grid codes are slightly different because we need to have more or less one specific grid code per country, and this is a challenge for the developers of products, but it's basically because the electrical grids are absolutely different in each country. I will explain a little bit our experience in Europe because Europe has a lot of integration of renewable energies, as exactly the same that happened in India, and I think it's a good opportunity to think about the lesson learned on this journey in Europe. Basically, in Europe, we have 27 countries, and for each country, we have a specific grid code. That this means that if we want to install in Germany, we have different rules that in Italy or in Spain. In 2016, the European Commission tried to do an harmonization of the requirements and develop the requirements for generator FG 2016-61 with the support of the Transmission System Operator Association and so on. But the fact is that this regulation was so wide and give the opportunity at local level to adapt the values and the parameters for all the capabilities that we will perform the testing and the certification. Something that we need to think when we talk about grid code is we need to see the requirements that I am fully agree that the grid code requirements shall be specific for each country and sometimes for some regions because we are talking about electrical grids and the electrical grids are different depend of the location. So it's normally developed at local level. I am fully agreed that should be something that shall be discussed between the different utilities on the country. And the second part is the conformity evaluation, how to do the evaluation of the compliance for these requirements. I think it's very important to show that at European level, we have 4 different conformity evaluation methods for the different countries. And there are big differences, I will explain later. And I think that this is something that we need to have a common framework that how to do the evaluation of the compliance for these requirements. This is the 4 methods that we have at European level. I will try to do a short summary because I know that I have a limit time. But basically, the first method is each utility perform his own evaluation about the grid code compliance based on the grid code requirements for the power plant. There are not any type of third-party company accredited to do this testing, and everything is handled by the utility. So this is the first, that this is applicable in some European countries. The second one is the testing of all the generation units, power generation units, PV inverters, wind turbines, EV chargers, all type of generators. And this testing shall be done by an accredited laboratory accredited for these activities. So this give the authorities a safety that all of these testing are doing in accordance with a minimum requirements, with a minimum accreditation requirements. So this is something that is implemented in some countries. For example, Italy. Italy requires the testing of the generators. Testing and certification of the generator. We are talking about not only perform the testing for the generator, we are talking about to do the testing and the final certification. As you know, the testing of one of the generator is you are doing the testing for one sample, that is one PV inverter or one wind turbine, and the certification includes the family of all the models that are included with similar characteristics to this model tested. Testing and certification shall be done by an accredited company, and in this case, testing laboratory and certification body, and according to the requirements of this specific country. We are talking about different grid codes in Italy, Germany, Spain, United Kingdom, Belgium, France. So we need to the company that perform the testing and certification shall be accredited to these activities. And the third one, probably is the most complex, is the certification of the power generation system. When we talk about grid codes, we are thinking not only about small inverters that you can have in your house. We are talking about utility scale power plants, and the conformity evaluation for this power generation system is performed by a third party accredited, and is based on simulation, and is based on the certification and simulation of the power generation unit. This solution, the certification of power generation system by a third party, is implemented in Germany and in Spain, and give the possibility to the local authorities to see and to verify at power plant level, not generator level, the compliance with the requirements of grid code. So in the power connection point of this 110 or 166 kilovolts, you can see if the active reactive power and all the requirements are in compliance at power plant level. So this is an incredible advantage in compared with the evaluation based on power generation units. Something that we see into the grid integration that will be not the future, will be now. It's the storage generation models. It's a fundamental integrate batteries and storage system into the grid. If we have a high penetration of renewable energies, if we want to change from synchronous machine to this type of technology, we need to have the support of the batteries, because of course we have the dependency of the wind of the sun, so it's very important. The storage generation modules are very linked with grid forming requirements. At European level, we are finishing the new requirements for generators that will integrate the grid forming requirements. This means that we will have, with the storage and with these grid forming requirements, similar characteristics for PV and wind that we have for synchronous machine. So this gives us a lot of opportunities to handle the grids in a safety manner. And something that is new and it's important for the smart grids is the vehicle to grid. At European level, we saw that will be a lot of EV chargers that can provide energy to the grid. And these EV chargers need to be in compliance with the grid code requirements, because at the end will be a generator, and we need to have a clear view about the capabilities of this type of EV chargers. I think it's very important, this type of bidirectional EV chargers for the smart grid in combination with the batteries, because we can handle all type of generators that we can have dependent of the needs of the moment in the grid. And something that basically in our experience we develop at European level, this is a standard. I think it's a very important standard for the evaluation of generators, because we are not focusing only into the definition of the parameters. As you know, you can have some needs in some moments about power reduction versus over frequency versus or power increasing versus under frequency. And this standard 5549-10 define the conformity evaluation method, how to do the evaluation of the generator, but not only in terms of the defined parameters. We are talking about the range of parameters. We are not doing only testing for a specific firmware or software version. We are doing a testing for a full range of capabilities of this set of parameters. And this standard is very interesting because it introduced at European level the use of hardware in the loop. I think that we hear something about RTDS, real-time domain simulator. Hardware in the loop is an incredible tool to use not only for power plant, it's to use for power converters and power plant controllers, and give us the opportunity to do the test in a real-time domain. So we are not doing all simulation as in other software, for example, DSilon, PSSE, or PSCAT. This is a real-time simulation, and it's really valid, and it's implemented in some countries as a basis to access to the grid. So I think it's a very good opportunity for smart grids. Is fundamental because in terms of testing, it's so complicated, but in terms of using this hardware in the loop tool to do the validation of this smart grid will be a great advantage because we will see all the change and the behavior of this smart grid.
Thank you. Thank you very much, Miguel. I think it's a very interesting presentation because it is describing some really developed approach for certification and testing on very specific issues for smart grid. You see, really this is, okay, it's very specific to Europe, but it would be interesting to see in the other part of the world such approach, even though it's organized by the government or it's organized by the industry or the utilities themselves, you see, to come up with schemes. And of course, the scheme is interesting, but it's nothing if you don't have the possibility to have independent assessors like UL. I guess that's what you're doing, and you're based, I guess, in Europe. But I guess UL could organize that kind of service anywhere else in the world to assess such complicated solutions, energy solutions, and they are more and more complex actually. And this is, of course, this is the invisible part of the iceberg. But without this, there is no way we can come up and deploy massively a lot of the new technologies and with all the buzzwords we hear, and make that in a sustainable way and really bring more benefits than issues. Because we have to keep in mind, the more technology you introduce, and the less reliability you might end up with, because the more equipment means more possible statistically more possible failures. So thank you very much, Miguel. I'm just looking across the room in case someone would like to ask you a specific question. Of course, you're remote; it's not easy. Would anyone have a question for Miguel? Looking around, I don't see any, but I thank you very much for having prepared this for us, and I think it is a very, very good sample and case study. Thank you very much. And
Thank you.
Here you have Mr. Rajput, our head of regulation, who will ask you the question.
I think this system is working of microphone. This is not working. This is dummy.
Dummy, but standard.
Gives a confidence that you are having something. Anyway, it's a lighter note. See, we have IEEE 1547, IEEE 2800 also. Are these not sufficient that we make the systems, we build the system, develop according to these standards? And whatsoever this complicated that chart, which was not visible also, flow chart, need to be followed. That flow chart, a broad flow chart, could be made part of IEEE 1547 or 2800 as the case may be, and that should be sufficient for the conformity assessment. And one more thing is, why I am raising the question is, once you have checked the system and say there has been a major fault, system has been out for say 1 month or 15 days, your generating unit or generating system, whether that test need to be carried out once more, conformity assessment.
A difficult question to you. Go ahead.
Sorry, I am not telling that. Okay, I am not telling that IEEE 1547 or 2800 is not a valid standard. I think it's a very good standard. Sorry, I believe on this standard I am using during the last 50.
Oh, we cannot hear you. We lost you. No, we lost you. No, we cannot hear you. Not yet. Okay. Oh.
You can hear me?
Okay.
Let me 1 minute. Sorry, I am.
Okay, go ahead. We can hear you now.
Okay, perfect. Okay, I think it's important. I'm fully agree with you that IEEE 1547 and 2800 is a very good standard. I am using during the last 15 years to do North American certification. So I think it's very, very useful at generation unit level. So at generation unit level is very good. If you are checking that the converter or PV inverter, storage converter, or other type of generator are in compliance with this standard, it's good. But if you want to manage at power plant level, not, for example, a power plant of 100 megawatt or 200 megawatt, with this type of generator integrated with compliance with this standard, I think that it's important to have more information, and this information can be provided by the simulation at power plant level, because you will see the exact values and the real values in the power connection point. So I am not saying that these are not a very good standard. This is probably one of the best, but the combination with simulation at power plant level give to the utility a lot of information and a real view of the behavior of power plant level, not at generator level. So I think it's some of the lessons learned in other countries does implement this type of evaluation at power plant level to see the real behavior of the system, not at unit level, at system level.
So in a nutshell, it's really adding a kind of holistic system approach to this question about let's certify, let's allow connection, let's allow the operation. I guess NERC also has some specific grid code, because here Miguel has been describing a European, pan-European approach. So I know in the US, for example, NERC is coming up with a lot of grid codes. They are based, they reference standards, they reference good standards, but they don't just stay at the level of each of those standards. So for the sake of time, we cannot give, okay, go ahead, have the last word on this, please. Oh, we cannot hear you. You need to use the right microphone.
It's for me.
Can we know that which specific simulation tools they are using? Some specific simulation tools for conformity assessment and carrying out the simulations. What are the specific softwares or the software tools they are using? Just for an idea, we want to know.
Very good question.
Okay, normally I can tell you that at European level, we are using Power Factory. That this is a software that is commonly named DigiSilent. That is very useful for to see the compliance with some requirements. But this is not only this software. We are using DigiSilent. We are using PSSE from Siemens. We are using PSCAT. That this is electromagnetic transit software. So all of these three software are used not only by the certification body, by the utilities, European and other countries, not only in Europe. And I think this type of tool are very useful. And of course, hardware in the loop. Hardware in the loop at power plant level, for example, are mandatory in Arabia Saudi. All the power plants need to be in compliance with the grid code based on this type of simulation with RTDS. So with these three software and hardware in the loop, it's an incredible tool to verify the compliance at power plant level.
And whether SIME software, CYME, SIME software by Eaton and ETAP, they are also capable and are used by the utilities there.
Yeah, the ETAP basically is a software that we are using for protection settings. It's a protection and source circuit. It's possible to use, but to do some simulation, the normal software that we are using are more the software that I mentioned. But the ETAP is one of the tool that we can use for some specific requirements.
Okay. Okay. I think we covered properly the topic. No, I think for the sake of time, you see, and we need to give to respect the coming speakers who have also very exciting things to share with us. And I think we need to thank very much Miguel, and join me to applause Miguel presentation. And of course, anyone who has questions or whatever, they can definitely, I'm sure, exchanging emails and being in touch with Miguel. So,
the next
thank
topic,
you.
Yeah, thank you very much. And the next topic is case studies, implementation challenges, and way forward by Mr. Gopal Nariya, Vice President, PRPL. And there's as Tata Power is a leading utility, and they are the fit person to talk about this particular area. And I am very happy to introduce my friend, Mr. Gopal Nariya. He is the Vice President of BSES Rajdhani Power, or PRPL, part of Reliance Group. He is currently taking care of central engineering services and automation, smart metering, demand side management, and PAT, energy audit and analysis, non-tariff, income and asset management as head of the department. He possesses three decades of rich experience in power sector. He was previously associated with Reliance Infrastructure Limited, Gujarat Industrial Power Company Limited, and the Ahmedabad Electricity Company Limited, all leading companies. He is also associated with various professional organizations like IEMA, the CEA, BS, etc. And his aspiration is to develop digital utility with hyper automation in the area of smart grid, smart metering, term, ADR, and make India leader in providing digital solution. And we are very happy to hear from you, sir.
Thank you, sir. I'm audible, right? Okay, thank you. So today, I think you have already introduced myself and my company BSES Rajdhani Power. So not taking much time, I will briefly, very shortly, quickly go through the case study for which I am here today. I'm going to talk today about a project, a unique project, particularly distribution utility level, a battery energy storage system we are we are in process of, we are in final stage of implementation. So this is the basic project. It is a 20 megawatt battery energy storage. We are implementing it at Kilokri, a place close to Ashram Chowk. It is being built on boot basis. Developer is a Kilokri BSES Private Limited, is a KBPL, the consortium of IndiGrid and Ampere Hour Solar Technology Private Limited. It is being funded by ZF, 70% concessional debt based funding. We are the off-taker, BSES Rajdhani Power Limited, built on operate basis. Concession period is 12 years, around 8760 cycles is expected the delivery. Capacity is 20 megawatt, 40 megawatt hour. The 2 cycle per day is the operational requirement. So we conceived, we got this DRC approval somewhere in the May 2024, and we are expecting commissioning by end of this month. So basically, battery is listed around 12 container, each is of 4.179 megawatt hour capacity, 2.08 megawatt. Operating voltage at battery is minimum 1123.2 to 1497.6 is the maximum running of lithium iron phosphate is a technology. Each cell is 340 ampere hour. Basically, it is cooled liquid cooling method adopted. Fire protection is basically condensed aerosol fire extinguisher system with water as a backup, high velocity water spray system. For power control system, FIMAR is the main supplier, 2.5 MVA, there are 12 modules, operating voltage is 978 to 1600 volt. So basically primarily this site is located in a densely populated area. So our primary consideration apart from functional and the storage requirement was a safety of a system and safety of the people around the installation. So we must follow the best practice, the compliance to the local norms, clear certification and NOC from the local. That's a most essential consideration. That's where we have a learning. We are here to share that part because most of the people who are going to who has already planned is going to face the same issue. In safety, we have a primary approach. The best benchmarking practice is fire prevention, and then protection and suppression. So we ensured compliance to NFPA, UL, IEC, BSES standard at system level and at component level, and functional compliance of the safety. All that has been done. Specifically, key design feature of fire protection and suppression was UL certification at battery and container both. IC certified power system is being used. All the essential protection as per the norm plus, even though it is 7.5, we are also going to have a high velocity water spray system for protection. Control, auxiliary system, subsystem, everything is have a dedicated unique fire suppression system, fire protection system, detection and protection both. So possible, the source of fire that we keep in mind was thermal runaway is the biggest risk, is particularly this battery technology. So that was a primary our cause of concern. Everybody, so that's a learning globally we adopted from that part. Electrical short circuit and naturally the outside fire protection to the installation. So this all the benchmarking standards we have used, we adopted. I think we ensured compliance at component level and at the system level. So primarily NFPA 855 was the installation standard, that was one, and another one is UL 9540 and 9540A, both, that was the main key, and all other all other at various particular functionality level also we complied, like NFPA 68, 69 explosion requirement, explosion prevention requirement, even carbon monoxide bed detection system, everything we have kept in mind and we have considered in designing the system. Even IS 17385 and 17068, that is already a quick adoption of IEC 629355 has already been ensured the compliance. The enhanced safety fire at battery container, if you look at fire detection system with CO2, H2, smoke and temperature sensor based system has been considered under UL 9540 requirement. So fire suppression system is basically aerosol and water fire retardant system at container level. Battery particularly is being protected in case of probable risk, just to prevent a risk of the fire convert into an explosion. So detection of flammable NFPA 69 compliance for even get CO2 and H2 activated ventilation system is there in the system. In case the preliminary detect any of these two gas is detected, so primary the first action will be ventilation, and once the limit is crossed, the second one will be activated, the active fire protection, say aerosol base and water. The water is a backup, but aerosol based fire prevention mechanism is there. The NFPA 68, the explosion venting, the defragmentation provision is there. The very important system is a proprietary arrangement of one of the developer is early thermal runaway detection. It is AI/ML based tools they have developed. It is proprietary. I don't know much. I don't have much insight to that system, but it's interesting. It is capable to detect the feasibility or probability of thermal runaway condition, and it will put the system in safe mode. Maybe the shutdown or maybe the whatever the relevant condition, it will take action. The container itself is 2 hour fire rated container. Primarily that requirement comes because we are installing it in a very small space. 1 acre land is being used for 20 megawatt capacity. So we were not having enough space to comply 17387, IS 17387 requirement and 17067. So that is a typically electrical norms in India for any electrical installation within the building, but that's quite liberal. I mean, not liberal, luxurious in terms of space requirements. So that we were not able to meet all requirements. So that's the additional precaution of 2 hours fire rating was considered for container design. So that was the approach, restricting the supply of oxygen by activating aerosol in case of risk of fire. Once the primary gas detection level goes to certain level, the propagation of the restriction of heat propagation from one module to the package and adjacent battery constraint was also important consideration. Certification level, UL 9540 certification at cell level, module and rack, 2 hour fire rating, we already discussed. Clearance of NFPA 855. All other part we I think talked on. Particularly space part, the basic requirement is 10 feet between 2 containers, NFPA 855. But fortunately, there is one important aspect. In case if we have a container with 2 hour fire rating, that we can reduce it to 3 feet. So that was the very interesting part of that standard, and it helps us a lot to have a maximum capacity, particularly in a very small space. So key takeaway was, as we discussed, for us buying a best product, adopting a best practice in installation, testing commission. We are also getting UL support, particularly final testing of system and the certification at system level once the system is installed. So UL is supporting us for final testing in this. But even though we were complying all standards, and the clear challenge come to us when we approach the authority. So are you ready to certify us whether we are okay in this densely populated area, particularly will you give us a fire NOC, whether we will have a electrical inspector certificate. That we already learned from our Delhi the sister utility. They have a good experience, Tata Power. They were also having said, fortunately in this project, our hand were held firmly by CEA. They are ready to develop regulations specifically for battery. They have taken all the input, and very shortly they are going to notify that regulation, so that we will be clear whether I need to have a electrical inspector clearance. That's very important certificate, because unless I have that part, and unfortunately anything goes beyond that, the consequence we have faced in Delhi, Upar Cinema Kand is the one example. So it is discussed across India. So we don't want that sort of situation. So fortunately, EIC is not required in the present frame for any electrical utility. We are empowered for certification, but we need an independent authority certificate. The second part is fire NOC. Fortunately, standardization adoption through regulation and the legally adoption, that part is still missing. We need support for that part. So that's the case. Basically, that's a key takeaway of this project. Thank you.
Thank you. Thank you very much. Thank you very much.
You.
It is a very interesting case, because we see that it's no more just a question about technical standards to have new equipment that would work and interoperate, which has been actually most of the discussions for years. Now it's about, okay, of course having this, but having this installed in the real world, close to customers. And there are a lot of aspects that, once again, are in the invisible part of the iceberg, right? I was puzzled by, on slide number 8, you had a list of 15 standards, if I remember well. Okay, this one.
Right.
It's very interesting. Now, there might be very difficult questions now asked,
Yeah.
which is, did you require the supplier to comply to this list of standards, or did you ask for a proposal to the supplier that came up with this list saying, you know what, our solution will comply to this?
Basically, our approach was to purchase a system which is compliant to the best practice and best standard available in the market, not in locally, globally.
Right, but when you say the best, they all claim to be the best. So,
right,
who's been writing this list?
Definitely, we got it from the developer part.
Okay.
Actually, we were not clear. Frankly, Richard, we were not clear when we conceptualized this project.
Okay.
What all standards?
I thank
this
you.
Evolving section of this.
I thank you for the frank response, because this is very, most of the time, this is the case, where the customer it's unclear. You see, where is the border? Where is the fine line of liability? And how are you decide how the customer will decide to pay or not when it's delivered? And what will be the conditions to get the payment from if I am supplier? And it's not easy. You see, I have a lot of experience of I have been purchasing for very large utilities billions of equipment yearly, but also I have been developing some equipment. One part of my career, and I've been responding to requests for proposals. And the key is requests for proposals. You have 2 or 3 weeks to come up with a technical and financial proposal, and you have to actually say that you're going to comply to a list of standards, possibly a list of standards that the customer is proposing. Customer, they might not have the knowledge to really come up with the right list of standards, but what they do to actually transfer somehow the responsibility to the vendor, they copy-paste huge list of standard, whatever, and then the supplier who has 2 or 3 weeks to come up with a proposal and even think about a solution that it could actually provide in a given time for such low amount of money. What they do, usually the suppliers say, yes, we're going to comply to whatever list of standard. And why they do that? It's because they know that the customers don't have the capability to assess that each of those standards that the delivery will comply. And this is a completely it's a monkey business, you see.
We do the same thing in the most of our purchase, frankly. And unfortunately, sometimes we do also have certain, it's compulsory for us to do that because of certain condition, very typical condition of site, maybe typical requirement, maybe we have to comply with the existing legacy system. So that's where typically, but fortunately, in this project, we know that there are so many constraints. If we will restrict particularly in our demand with technology and compliance or standard requirement, we are not going to see the end of this. We were supposed to be open-minded with broad heart so that something realized on the ground. That was primary.
But up to now, you see, if there is a huge list of standard that does not really comply to even 10% of the list of standard, well, what's the matter? Maybe simply there would be a loss of reliability or etc. But now we're talking about something else.
Safety.
It's even safety and life of customers So, as a takeaway, and without pushing the envelope and abusing too much about your kindness to frankly respond to those tricky questions, the key is really to put the finger on this very touchy aspect, which is the responsibility of the one who are requiring standards to be complied to, and also the responsibility of vendors who should really question even the customers, saying, you know what, how are you sure this is what you need? And if you don't have this dialogue, this adult dialogue, you see, we're going to end up with terrible situations. So I think it was an excellent application case here, and allowing to raise this very, very tricky new challenges. Thank you very much, and I'd like to invite everyone who joined me to applause you. No, thank you. And BSES is really a leading utility, well known worldwide. Thank you.
Yes, last speaker. Friends, the last speaker is our friend Mr. Kishor Narang. Though the topic was not given, but he is involved with most of the standardization activities in both in India as well as with IEC and related things in other countries. And we are happy to introduce Mr. Narang. And of course, he is having his own organization. It's called Narnix Technologies Private Limited, and he has vast experience of 46 years experience in various aspects, including deep involvement in the standardization. And we are happy to, he has worked in all these areas of the smart grid, especially standardization, electrical, IT, digital infrastructure, cyber security, and standardization, whatnot. Involved with all these standards organization like IEEE, IEC and ISO, ITU. Friends, we will be happy to hear from Mr. Narang. Only small request is that now it is 4:40 or 40.
That's not my problem. I'm going to take my own time. Just joking, just joking. No, just joking. I can be, so I have no presentation, and that was the reason I didn't make any presentation, because my slide decks tend to be pretty long and it becomes more of tutorial. So I thought we'll go extempore so that I can, switch my gears and shut down whenever it is needed. So I think I'm not going to talk about, initially I think since we are talking trends and challenges, since I'm a design engineer, technologist, let me start with technological trends, and then we will see how do we map them to our ecosystem, our standardization, and all those other current problems, imperatives of the society, business, industry. So if you really see, the disruption is everywhere, and the future is uncertain. But no one knows what the world would look like a decade from now. As we head into the future, we are surrounded by disruptive innovation, and tech disruption will be driven as much by methods and systems as it is by devices which we normally associate disruption with. The pace of innovation today is incredibly fast. With new things getting discovered daily, future trends in technology are very diverse, very intertwined, and very promising. There are several developments that have and will continue to shape our business strategies. From automation to sustainability, different organizations are adapting to whole wave of consumer or the client's preferences. And when talking about disruptive technology, I think I've heard a lot of buzzwords about disruptive technologies and profound technologies. So let me demystify these two simple sounding but very interesting words. What is a disruptive technology? Disruptive technology is the bearer of tremendous opportunity, but equally a harbinger of obsolescence, because when a new technology comes, some old technologies have to make way for it and they become obsolete. And technology's impact on society and business is substantial, if not underestimated. Though product cycle times are accelerating, the underlying technologies unfold over many, many, many years. Within each trend, there are multiple enabling technologies, and all at various stages of maturity and adoption. And the most profound technologies are those which disappear. It's a very confusing definition. How can a most profound technology be disappear? Actually, they weave themselves into the fabric of everyday life in such a way until they become indistinguishable from it. So let me give you an example of some most profound technologies. What are one of the earliest most profound technology that we do not know? Maybe some of the, if not, we don't go too back in centuries, maybe electricity itself. Do we question it? We take it as a given. It's a different thing. We still have around 1 billion people who do not have access to it, but still we take it as. Now, in recent decades, internet is a given. And so anything that starts, and one of the most interesting example would be for disruptive and profound technology would be AI, artificial intelligence. We have seen this progress in or proliferation of AI in the last 10, 15 years. But has it been just a new technology? No. You must have heard a lot of people saying, I've been working on it for the last 40 years, 50 years, 30 years, and all that. That means AI has been there. But what happened? That it became so, it started proliferating in 2010 onwards. It was availability of 3 different aspects. I'm not going to take it.
Is it Narendra Modi?
No one. No, even if he is, I'll not. Don't worry. I'll just get it. Okay. I don't believe in that. That's a bad manners, whether it's Narendra Modi or whoever, or even Trump for that matter. Okay. Anyway, so the AI became proliferant because of availability of big data from many sources, dramatically improved machine learning and approaches and algorithms, and capability of more powerful computers and more bandwidth in communication. So AI has always been, a lot of people, scientists were working, but these 3 different or 4 different converging technological trends, they enabled AI to really proliferate. And so today, AI is also becoming from most disruptive technology about a decade back to most profound. Everywhere we are trying to apply AI. Am I right or wrong? And having a little, you can say, crystal ball gazing into the future, what are the other technologies on our horizon and a little beyond horizon? Space tourism is already here. And we could, drones could start making deliveries. We have started having some pilots, but still not large scale. But very soon we are likely to see drones flying everywhere, making deliveries of pizzas or whatever. Hyperloop is going to be very soon reality between cities. Even in India, there are some pilots going on. Space trips designed to send people to Mars and other planets are already being designed and planned. Virtual reality could replace textbooks in the next decade. Smartphones will become obsolete in next 5 to 10 years. Why? Because all that features would be embedded into maybe our body parts, our fabrics, our everything. Super tall buildings could function like mini cities for the next 20 years. We could rely entirely on renewable energy by 2050. This is one of the interesting technology trends. Biotech is today at the forefront of the human progress. We are talking about bio-digital convergence, convergence of biosciences and technology. And that is bringing us a lot of interesting aspects, like human augmentation. Machines, could start thinking like human as early as 2025, which is already happening, AI. But then, we have a lot of prosthetics which give us a lot of additional skills, and they compensate for our physical and all other handicaps that are creating. Then we have like metrics, although we are looking at amalgamation of technology into the human body, so to make us cyborgs. You must have seen Matrix and all, you see all those Marvel series movies. Hyper-automation, autonomous things, Internet of robotic things, and then the basic technologies like edge computing, Web 3.0, and metaverse. All these things are becoming really, you can say, relevant today, and everybody, all the techies and tech aficionados, they are looking at how do we apply these technologies to different domains of business, society, industries, and all that. So very soon you will see a lot of use cases within your own this thing. Like if you remember, last year, I think, or last to last year, there was some demonstration in DOT on 5G use cases for power sector. And what they were showing, high definition video streaming of the substation monitoring, even drones trying to do monitor of the transmission lines and all that. Yes, they are a bit exotic boutique use cases as of today, but very soon they're going to be realities. Now, these technologies, then 5G. And what you see 5G today is only the beginning. The Carl Benz automobile for the internet, that was, the first Carl Benz automobile in 1800 something that was brought in. So today 5G is something of that basic level of the future communications strength that we are looking at. What we are looking at is very, very interesting and very, very profound features in communication ecosystem, communication technologies and all that. And 6G is further trying to bring us universal autonomy, ambient intelligence, and I can go on, and future networks are something like one network, through one network, you could absolutely address all customized use cases by network slicing and all that. So these are different technologies that are already on the horizon. But then what happens? These technologies, they come with their own ethical challenges. Whether it is cybersecurity, whether it is privacy, whether it is digital trust that we are talking about, they come with their own challenges. So when we talk about technologies or deploying technologies or leveraging technologies, any use cases, domains, we need to keep those things are also in mind. And now taking a little step back and looking at the current scenario, current landscape, global landscape, and the imperatives. So going beyond technology, we are talking about climate change, net zero goals, and going carbon neutral imperatives and initiatives. We are talking about energy security, like examples were the recent challenges that Europe was facing due to geopolitical conflict. You remember the first winter of Ukraine war, Europe was really facing the brunt of lack of gas supplies. And they really faced a hardship and having a very, very cold winter at homes of the most of the people. Then clean and green energy, coal, gas and all these things, they meet still the 3/4 of the energy demands. Energy efficiency, electricity excess, global digital population is increasing today. Okay, digital transformation we are talking about. Then AI as a double-edged sword. Growing carbon footprint of digital, we are deploying digital infrastructure left, right, and center everywhere to bring digital transformation. But is anybody looking at the growing carbon footprint of the digital infrastructure? Nobody is looking at. Then the meaningful, safe digital life of our global citizens. Nobody is really worried about, though there are a lot of talks about, but not really some proactive actions have been taken. Industry 4.0 to Industry 5.0. Industry 4.0 was all about automation, ICT. But we have now started talking about Industry 5.0, which is talking about man-machine collaboration on the shop floor and sustainability and bioeconomy and all those things. And sustainability and resilience have come to the core of all kind of infrastructure, cities, or any kind of, whether it is your grid, whether you talk about cities, any infrastructure, sustainability and resilience have become the core. And then last but not the least, greenwashing. Greenwashing is one of the major issues that we are trying to fight the battle with, because all these big claims that you hear, we will go carbon net zero in 2050, 2060, 2030. They're all greenwashing, because if you scratch the surface, you will find there's no true net zero, because of what they're trying to, they're trying to offsetting your energy footprint with a green energy being produced by somebody else somewhere else is not a net zero. I'm sorry, that's not a net zero. It's just offsetting. Net zero is when you within your own premises can go this thing. So I think rather than net zero, we should be talking about decarbonization as much as feasible, and then compensating, offsetting with the overall, you can say global or national averages. Then there's one of the major aspects, a myth about the climate change. What is the misconception? Everybody thinks we are facing the same storm. But the climate change reality is, it is the same storm, but we are all in different boats. A larger ship will face the same storm in a different manner, while a small ship will get impacted in a much different manner. But coming to, so you want me to conclude?
I guess it would be wise to.
Yeah, so I think now, I'll just take 1 minute to conclude, link it with the standardization. Now, we are facing all these technological challenges, or technological trends are there. We are all trying to use it, but how do we deploy them? How do we integrate them? So there are two ways of doing that. We first let the problem precipitate and then try to standardize, then try to solve the problem. Or we have forward-looking approach to standardization. We look much more into the future and be proactive in standardization. So I can give you an example. In our smart grid, smart home, or any other this thing, we are basically reactive in standardization. Once something starts creating problems, start paining, we start taking medicine, or we try to bring harmonization, interoperability, and all that. But look at the communication side, 2G, 3G, 4G, 5G. They have been always looking forward. So there's a standard-driven research, then standards are developed, and the ecosystem develops. So before the 6G is deployed, the ecosystem is already ready. So I think we need to have, identify our problems in the future and have proactive response to standardization, innovation in a structured manner, so that we can actually bring benefit to the society rather than disruption to our way of working. I'll stop at that.
Thank you. Thank you very much, Kishor. Join me to applause Kishor. Kishor's know really everything on, I would say, everything in our area. And he has been a mentor for many of us. Of course, the challenge is when we have to give him a limited amount of time to come up with, he has to make decisions. Okay, what is going to select? And this is very, very difficult, but thank you for the balancing act, because you've been addressing a very, very high level concept here. Thank you. Thank you. So this is the last presentation of this session 2, and now we have a few minutes to come up to some conclusions or takeaway. and I will actually even cover with what we've been doing this morning. So this morning we addressed emerging technologies and the relevant standard landscape, and of course it was really exciting because we had a very good turnout in the room. We had really very high quality presentations, well prepared, well structured, and really covering different areas that were no more just promise on the future, but real things going on and that have been going on for some time on technology. And then this has been the opportunity to discuss how the SDOs are developing those standards, what they're doing to try to work together, and for sure they do the best they can do, each of them to contribute. And also it was very interesting to see how regional standardization organizations were actually acting and being the connector between the international standard development organization and what's going on in the different regions and countries. And we had presentations about BIS and also about Europe and how Europe is interacting with India on standards. Now, this afternoon, we've been pushing forward the timeline with actually future trends and challenges. We had 2 utilities presentations and 2 leading utilities presentation. And I always enjoy very much the presentations from those specific 2 utilities because I don't know how they do that. They are really at the cutting edge, and even they come up with so clear and real things. You see, very often utilities are just coming up with so many things that you could wonder if it's not just copy-paste what you find on the web. No, what they are presenting is real things, real advancements. And of course, definitely go to visit this smart grid lab of Tata Power. But the BSES case was extremely interesting because what we are now addressing is how the industry is really counting on standards to procure new solutions for the real world and the real life. And we see that what has to be covered is, I would say, no more just the usual technical questions that have been addressed and entertained in events like this one worldwide, which was really about having something that can work, that can provide some performance, or that can interoperate. No, we are going really much further, because now we have to address things that are the invisible part of the iceberg, which is what is needed to have those real systems in the real life. And of course, we need to avoid a lot of potential unintended consequences of having those solutions on the ground. You see, someone that was not addressed here is robots. Robots. Hey, there are robots everywhere now. When I travel, I was amazed to see in China, for example. In China, there are robots in the restaurants, in the hotel. And where I was shocked is not to see the robot, because we can see, if you go on the web, you see, look at the Boston Dynamics videos. It's just incredible what they can do. No, what impressed me is to leave robots alone interacting with the humans. You see, I was going to my room, and there was a robot that was standing by the elevator, and that got in the elevator with me, or I was getting to the elevator with the robot, and the robot was delivering some food, and I tried actually to play with the robot, you see, trying to make the robot thinking really where he should go, and I say he because it's almost a, okay, it was just incredible to see how those technologies you see now. The issue is not to have the technology that can work. The issue is to have the technology that can interact with humans, because humans are can be quite unpredictable. I close on this. It's really, I was just extending the discussion we had on the BSES case with, now you need to consider interacting with the real world. Of course, we had the privilege, and we were really honored to have a very high-level regulator with us today, Mr. Rajput, who, and it was really interesting to have also a very unusual, you see, usually when you want to discuss at a conference with regulators, it's very well, it's extremely formatted, polished, over-controlled. But it's of no interest. I mean, personally, I've done that. I've been advisor to regulators in the US, actually, to FERC chairman, and also the California Public Utility Commission. But having a direct and frank discussion is really just incredible, and we thank you very much. And we also had from UL a discussion about what can be tested, how those new systems and solutions should be encompassed, what should be done. Of course, he focused on a very, very specific case, which is Europe and the European grid codes. This was the occasion to see that more and more we are moving ahead, not just about a piece of technology, a cabinet, a solution that can be delivered or purchased on the shelf. We're moving ahead with a quite complex assemblies of many different things that can be material, but can be also not material. And there are many invisible dimensions to be mastered, and this is really the role of the grid codes. Of course, we had the example of the grid code in Europe, and there are many of those, and I'm also personally involved in different grid codes for the European regulator. But we see that elsewhere in the world also this exists. I mentioned NERC, for example, for a long time. You see, they come up with their very specific grid code. So I think we have covered a lot today, this morning, with here and now and what's going on with a very seasoned people, and this afternoon more on, okay, we said future trends, but this is really what we should pay attention to for any next step that would be foreseen by any of our stakeholders. On that, I would like to thank you very much, because I see that there were some people who were there this morning and again this afternoon. Thank you for your patience, because I know it can be very long to stay seated an entire day, and especially on that kind of topic. And thank you very much for the lively interaction we had here. And of course, we need to thank Disha, who has been actually doing the heavy lifting, putting up all together this program, getting in touch with everyone, and to make this possible and happen. And of course, our chair this afternoon maybe would like to say something.
Of course, this is always a topic which is always current, in the sense that the standardization is a very important topic, especially in India. The reason is that some utilities are much advanced, like Tata Power, Reliance, Ahmedabad Electricity. Also, these companies, they're all really advanced in the nature, which are competing with the international benchmark. We want to tell that one example. I was doing some analysis of transformer failures for a particular distribution company. Then we were taking all over India, benchmark of which utility has done something like that. But in that we found that Tata Power and Reliance came on the top, which is competing with international benchmark. I was really shocking, it was 0.75%, whereas some electricity utility companies were 8%. And that too, it is a suppressed fact. It may be 12% or 15%. It is disturbing. So friends, so we are in India, we have a very peculiar system. In the sense, some utilities are much advanced. And most of the, I am sorry, because I am also associated with the government organization most of my life, and I was also heading the certification authority, laboratory. So I know that what is the reality is that the gap is too much between manufacturer and utility. That is a major problem. So there is, as I mentioned, that the specification writing itself is not done. It is just a copy and paste.
That's the point. That's the point we made, and this is really the cornerstone of this entire the real foundation of this entire day. So I guess we have been working hard the entire day, and I guess you all deserve a bit of rest and enjoy the rest of the day. Please join me to thank the audience, the speakers, all the speakers, and the organizer. Thank you. Yeah, and of course, we need to do the group photo here. So all the speakers, please join us here on the dais.
So, and thank you, Richard. You were the chair for this session, and I didn't see you on the chair itself.
Oh yeah, well, we have the passion. We had the right people here, so we made the most of it.
Thank you so much. So I thank you all. Richard has already thanked everyone. So I'd like to thank from ISGF for attending this event and be part of it. I request all the speakers, Rajput sir. Yeah. So we'll all gather for a group photo.